Alright everyone, so this is the fifth question which was asked in TIFR GS 2021 chemistry examination, and it says a 1 mm thick transparent crystal. So the width or the thickness of your transparent crystal is 1 mm. Of a metalloprotein absorbs 75% of the incident light of wavelength 500 nanometer. So percentage absorption is given, that is 75%, and wavelength of light is given, that is 500 nanometers. All right. What is the extension coefficient? We need to figure out the extension coefficient. Density of the crystal is 1.5 gram per cc. So density is also given 1.5 gram per cc. Molecular weight of metalloprotein is 100 kilodalton. So we have been given with these information. All we need to do is somehow rearrange this information and get to the value of extension coefficient. Let's try and solve this particular question. Before we get to the extension coefficient, let's understand that how actually we can find out the value of extension coefficient. What is the roadmap? So we know absorption is equals to log I naught upon I, which is further equal to ELC. So we have to use this equation, and through this equation we can actually get to the value of extension coefficient. So we have I naught value, that is incident radiation intensity, I, that is transmitted radiation intensity. We need to figure out the value of extension coefficient. We have length as well. But what about concentration? Do we have it in the question? No, we just need to figure out the concentration. If somehow I can get to the value of concentration, I can substitute over here and I can get the value of extension coefficient. So this is the correct roadmap. That is first step, we need to figure out the concentration. Second step, that is our final step, getting to the value of extension coefficient. Alright then, let's take our question to the first step. That is, we need to figure out the concentration. Alright. So what would be the units of concentration? Do we have to solve for molarity, molality? How we can get this conclusion? By options. Okay, just see the options. In options, what are the units? Molarity inverse, centimeter inverse. This means the unit of concentration is molarity. So we need to figure out the molarity. Okay. What is molarity? Molarity is number of moles divided by volume. Okay, so let's see how we can calculate number of moles. Number of moles is given mass by molecular mass. So what is the given mass? See, if I just look to the value of density, so somehow we have to find out the molarity of the given metalloprotein with help of the density. So let's see how we can get to the molarity of the given metalloprotein. So what is molarity? Number of moles by volume. And what is number of moles? What are number of moles given weight by molecular weight? So if I look to the density, that is 1.5 gram per cc. So we can say we have 1.5 gram of metalloprotein in 1 centimeter cube or 1 cc of solution. So that is what we can expect from this density given. So given weight, we can actually take 1.5 gram. Okay. Now what about the molecular weight? Given value in the question is 100 kilodalton, and we need molecular weight in gram per mole. So this is the only thing that we should be aware, right, in order to solve this question. That is 1 dalton is actually 1 gram per mole. Now from now onwards, you can remember this point, which will definitely help you in case the molecular weight comes in Dalton unit. So 1 Dalton is 1 gram per mole. So what we can say, 100 kilo Dalton is equals to 100 gram per mole. Okay, that is what we can expect from the molecular weight. So 100, right? Yeah, 100 kilogram per mole. Okay, because the unit is kilodalton. So molecular weight would be 100 into 10 to the power 3, we would be converting kilos to Dalton. Okay, so 100 into 10 to the power 3 gram per mole. All right, so this would be 1.5 into 10 to the power minus 5 gram, right? Gram and gram would be cancelled out and we would be getting our answer in moles. Okay, so this is the given value of number of moles. Okay, so we got the number of moles, that is 1.5 into 10 to the power minus 5. And what is the volume? Let's see. Okay, what is the volume? So over here we need to figure out the volume, and the given volume is 1 centimeter cube, because we took 1.5 gram which was actually present in 1 centimeter cube, so we can say the volume is 1 centimeter cube. Okay, so what is going to be the molarity? So the molarity would be given number of moles, that is 1.5 into 10 to the power minus 5 moles, divided by the given volume 1 centimeter cube, and we need to multiply this by 1000 because we are taking volume in centimeter cube, okay, not in liters. So let's multiply this by 1000. So what is going to be the answer? So the number of moles, or we can say the molarity, is actually 1.5 into 10 to the power minus 2, right? Because minus 5 into 10 to the power 3 would give you minus 2. So this is the given molarity, that is concentration. Quite simple. Okay, now just use the given equation. Absorption equals to log I naught. Let's take I naught as 100 because the given value is in percentage. 100 divided by percentage transmittance. If percentage absorption is 75% and initial value is 100, so definitely the percentage transmittance would be 25%, right? Is equals to E into length. Length of the system is in 1 millimeters, but you can say in option the length is actually given in centimeters, so we can convert 1 millimeter into centimeter, that is 0.1 centimeter, into molarity, which is 1.5 into 10 to the power minus 2 molar. Okay, so this would be 4. We can say log 4 is equals to E into zero point 0.1 centimeter into 1.5 into 10 to the power minus 2 molar. Okay, now we just need to figure out the value of E. We have calculators in the examination, so you can quickly substitute the value and solve for the extension coefficient. So let me quickly do that. Yep, so the answer is coming as 401.37 M inverse, that is molarity inverse, centimeter inverse. So option A is the correct answer, which is close to 401, that is 400 molarity inverse centimeter inverse. So that is how we can solve this given question. It's quite easy. You should be aware of only one thing, that is 1 Dalton equals to 1 gram per mole, and I'm sure from now onwards you won't forget this thing. Okay, that is 1 Dalton is equals to 1 gram per mole. I hope I'm clear on this question. We'll come up with the more set of questions from TIFR GS 2021. Thank you.